Pre-AP Pre-Calculus Free Response Practice Problem number 23. You cannot use a calculator. Consider the rational functions f of x and g of x to answer the following questions. Question A. At what values of x will the graphs of f of x and g of x have discontinuities? Explain your reasoning. I'd like to explain my reasoning first. The graphs of f of x and g of x will have discontinuities when the denominators are equal to 0. And that's because when they're equal to 0, there is no y value because it's undefined. Therefore, f of x is undefined at x equals 3. G of x is undefined at x equals -3 and x equals 3. Now, if you don't follow that last part, why g of x is undefined at 3 and -3, this little fella here factors into an x minus 3 and an x plus 3. I would encourage you to fully factor your denominator. Free response question. This would be worth 1 point. The reason, and then these two together would be worth 1 point. B. If h of x is the product of f and g, find an equation for h in standard form and then determine at which values of y will the graph of h have a horizontal asymptote. If no such value exists, state so. Give a reason for your answer. Well, h of x is equal to f, which is 2 over x plus 3, I believe. Yep. Times g of x, which is x minus 2 over x squared minus 9. So in order to multiply these together, because I don't really need those brackets, you multiply the tops together, you multiply the bottoms together. So the tops, we're going to distribute this 2 and get 2x minus 4. On the bottoms, we multiply the x times each of these, we're going to get x cubed minus 9x. Distribute the 3, we're going to get plus 3x squared minus 27. If we rewrite this so the terms are in descending order, h of x would be 2x minus 4 over x cubed plus 3x squared minus 9x minus 27. So let's go back to the question. Find an equation for h of x. In standard form, that means everything should be multiplied out. There should be no parentheses. Then determine what the y value would be of the horizontal asymptote. Let's do that. So looking at this function, the degree of the numerator is less than the denominator. I should be more specific. The degree, which function are we talking about here? In h of x. Degree of the numerator is less than the degree of the denominator. What conclusion can we draw from that? We can draw from that h of x has a horizontal asymptote at y equals 0. For your response question, you get 1 point for getting to that point. You get a point for saying the degree of the numerator is less than the denominator, and you get a point for saying that the horizontal asymptote's at y equals 0. C. On what intervals will f of x be bigger than or equal to g of x? Show a complete algebraic and sign analysis that leads to your answer. So we're going to have to take f of x, which is 2 over x minus 3, and say it's greater than or equal to, and we get x minus 2 over x squared minus 9. We're going to get all the terms on the same side. I'm also going to take the liberty of factoring this second fraction. It factors into an x minus 3 and an x plus 3, difference of 2 squares. I want to get this into one fraction. To do that, I need common denominators. I'm going to multiply the first fraction by 1 in the form of x plus 3 over x plus 3. If I distribute this 2 to this, I'm going to get 2x plus 6 over sum of x and 3 times the difference of x and 3. Now I get common denominators. Minus a fraction, x minus 2 over x minus 3 times x plus 3. To make this one fraction, the denominator we only use once, and we subtract the numerator. So we have 2x minus x, which is x. We have 6 minus a negative 2, which is like 6 plus 2, which is 8. Now at this point, let's go back to the question, because honestly at this point I've lost track of what the question was. When is this true? In order to determine this, we need to get everything on the same side, which we did. We need to make sure that we have it in one fraction, which we do. Now we're going to make a sign analysis. So what kind of things go on this number line? Things that would make the equation cross the x-axis, x values of where the graph crosses the x-axis, which is happening at -8. Other things to put on the number line, things that make this undefined. It's going to be undefined when x is -3 and when x is 3. Crossed off -3 and 3 because those are values that are undefined. Left -8 open because that's a value that is defined. It's where it crosses the x-axis. We are breaking the number line into parts like so. We're going to pick a test number in each interval, such as -10, -5, 0, and 10. If I put a -10 into this numerator, I would end up with -10 plus 8, which is negative. In my denominator, -10 minus 3 is negative. -10 plus 3 is also negative. If I divide or multiply an odd number of negatives, that's going to make this negative. If I put a -5 into the numerator, -5 plus 8 is positive. If I put it in here to the bottom left, -5 minus 3 is negative. If I put it into the bottom right, -5 plus 3 is negative. If you divide a positive by two negatives, it's an even number of negatives, that's going to be positive. If I put a 0 into the top, I'm going to get a positive. If I put it into the bottom, each of those I'm going to get a negative and a positive. Multiply these three together, we get a negative. If I put 10 into each of these, they're going to be a positive all the way around. Multiply or divide three positives, you're going to get a positive. So what is the answer? We want to know this right here, which is coming from this. When is it greater than or equal to 0? So it's greater than or equal to 0 when it's positive or equal to 0. Well, it's equal to 0. Well, let me make sure I'm writing down the question and the answer. F of x is greater than or equal to g of x on the interval from -8. It includes it because that's when it's equal to 0. Till it gets to -3. Doesn't include -3 because -3 is not a value that works in this function. And then it's positive again right after 3 and forever to the right. Essentially, it's this interval, and we include the -8. For scoring purposes, you get 1 point for naming the correct interval. You get 1 point for using the sign diagram, and you would not need this stuff. Let me put that in green. Stuff in green you wouldn't have to have. Stuff that's in blue and black you would have to have. And then you would get a point for, let's see, getting this correct into one fraction. And let's even give you a point for knowing that you would need to get everything on the same side of the equation. So that's 4, 5, 6, 7, 8, 9. There's 9 points. So that is free response practice number 23.